So I guess I should have just copied the picture over, but again, so if I draw the line x equals 2, I can get a fairly large zoom in of the area that I'm interested in. And this time, we're rotating it around the line y equals 8. So if this is x equals to 2, right here, then this here is actually where the line y equals 8 is going to be. So 2 squared is 4, times 2 is 8. So that should be the line I'm looking for. And I'm rotating it around this line. Okay, so we've already talked about this. Here is the rectangle that is sort of makes life easier for me. So what do you think? What kind of method would you use on this question? Well, you got a 1 in 3 shot. Anyone care to guess? Oh, so close. Yeah. Disc, washer, shell, all. Well, I guess at some point you could do all of them. But this is going to be a washer because there's this gap here, right? If this was the bar that I'm looking at, here's the gap. So that tells me when I rotate it, I'm going to have the washer situation. Okay?
Is that copyrighted?
The what?
Yeah.
Yeah, I guess I shouldn't spell it all. Was it all capitals in that?
Yes.
Yeah, I guess I shouldn't spell it all capital. Here, we'll just go like this. There you go. Okay, so it's going to be the big radius, which from the point of view of where I'm rotating, the big radius is going to be all the way down to here. So maybe we should write it out just so we don't skip over that step. It's going to be from 8 minus 0. Right? Because this is my top line up here, and this is my bottom line here. Then if I look at the small radius, the small radius is this gap that I want to remove. So the small radius is going to be 8 minus 2x squared. So that's the, from here, subtract that off. So now, the way the washer method works, it's going to be pi. We're still integrating from 0 to 2. So 0 to 2 of, let's see here, the big radius squared, so it'll be 64 when I square this, and the little radius squared. So maybe for now, maybe I'll be lazy and I'll just write it like this. Okay, where this is my big radius minus the little radius. Okay. Any questions about the washer method on that? Yes? Can I move the 64 is not quite a well, it'd have to be on both. Like I'd have to factor it out, right, if it was a constant. But basically I'm going to end up with two. You could think about it, you could separate it into two integrals if you wanted, but no, I wouldn't move the 64 out in this case. Okay, so we'll do the other one here too, on the line x equals to 2. So here is my picture again. And here is the region that I'm looking for. This time I'm rotating it around x equals 2. So if we continue to use the idea that these are the rectangles that we like to use, okay, this is obviously going to become a shell method. It's parallel. So to set up this integral, I need to know what's the radius function. So if I'm out here at x, the radius is going to be 2 minus x. And the height, which is how tall it is, the height is going to be the parabola 2x squared. So if I add them up, that means it'll be 2 pi, the integral from 0 to 2 of the radius function times the height function. So I think, anyway, we could do another step or two, but that's how we could set it up, and all we'd have to do is evaluate it at this point. Okay, so radius and height. And I'll just remind you that there is no formula sheet, so you're going to have to somehow remember the way these methods all work. And it's always based on the area of a slice. So whether that slice is a shell as it gets unwound and has area 2 pi rh, or a disk which is a circle that has pi r squared. So I know some of you are still working on this, so I'm going to just start putting my picture out to try to catch up. But anyways, I don't think I'll be finished before you. Okay, so this is a pretty good picture. You should double check that your picture looks something like mine. It's rotating around the y-axis. And again, if we were to start this question, my first hope is that since I have a function here which is defined for x, I would like to use dx in my integral. So let's see what that would do to me if I choose that. So here's dx. Okay, and I know it's a shell method because it's parallel. So let's just think a couple steps ahead. Is this going to turn into a horrible integral if I keep going with this on the shell method? Like, will there be multiple pieces? Is it a hard thing to figure out the radius or the heights? No, it looks pretty safe to me, so I think I'll take it. For the shell method then, again, the radius is going to be how far away it is from where it rotated. So the radius is just going to be x. Its height is this piece here, and that is going to be the top, which is the line y equals 8, and then the bottom here, which is the curve x squared plus 4. So that means the height will be 8 minus x squared plus 4. So that's 4 minus x squared. So if I wanted to set up the integral, it's going to be 2 pi from x equals, let's see here, 0, this is where it starts, until I get right here. So where do they meet up? Yeah, at x equals to 2, that's where they meet up. So my bounds are going to go from 0 to 2 since it's in terms of x, and the radius function times the height function. That's my integral set up and ready to be calculated.